Good morning, everyone. This is B. Ramarao from SRRS Government Polytechnic, Sirsilla. Engineering Chemistry and Environmental Studies, common subject for Diploma first year students. Subject code C204. Today we discuss about elastomers. Elastomer. Today our topic elastomer. Rubber is made by one is natural rubber, second one is synthetic rubber. This synthetic rubber is also called elastomers. Natural rubber can obtain from some trees, Hawaii, ficus, etc. It gives elastic compound called as a latex. In this latex, under the processing, then after form natural rubber. This natural rubber have monomers of isoprene units 2-methyl 1,3 butadiene undergoing addition polymerization to form natural rubber. These natural rubber have low tensile strength, it have high water absorption capacity, it undergoing oxidation, less resistance to chemicals, heat. So these character can be modified by the process of vulcanization. The process of heating of raw rubber with sulfur at 110 to 140 degrees centigrade to increase the strength of rubber is called vulcanization. After vulcanization, rubber properties should be increases by the formation of new bond between carbon, sulfur, carbon. Very strong bond. This bond should be increases some more characters of natural rubber. When it is vulcanized, it show high tensile strength, resistance to heat and chemicals. It have low water absorption capacity. It increases strength. It increases thermal and electrical resistance. It resistance to chemicals. These characters increases by the process of vulcanization. Elastomers. These elastomers, it is a synthetic rubber. It is made by synthetic compounds, butadiene, isoprenes, bunias, neoprene. These all are prepared by synthetic process. In this hour, we discuss about on the completion of the period what are elastomer, what are elastomer. Explanation of about elastomers, types of elastomers, advantages and disadvantages of elastomers, uses and applications of elastomers. In the completion of this period, you would be able to know about our contents, what are elastomers, explanation, types of elastomers, advantages and disadvantages of elastomers, uses and applications of elastomers. What is elastomer? Elastomer, it is a man-made vulcanized rubber. It is a man-made vulcanized rubber. Like polymer which can be stretched to at least twice its length, but when the stretching force is removed returns to original shape are called elastomers. Any man-made vulcanizable rubber like polymer which can be stretched to at least twice its length, but when the stretching force is removed, when the stretching force is removed, returns to original shape are called elastomers. Vinyls, neoprene, butyl rubber, these some examples of elastomers. Macromolecular material, macromolecular material, which returns rapidly to approximately its initial dimensions and shapes after deformation by a weak stress, which is macromolecular material, which returns rapidly to approximately to its initial dimensions and shapes after deformation by a weak stress, or any elastomers is a polymer which the property of elasticity. Any polymer which show the property of elasticity, which is stretching to at least twice its original shape, but the stretching force is removed, it returns to original shape, is called elastomers. An elastomer is a polymer. An elastomer is a polymer with the property of viscosity, viscoelasticity, generally having notably low Young's molded and high yield strain compared with other materials, are called elastomers. Elastomer is a big fancy word. Elastomer is a big fancy word, and all it means the rubber, it is rubber. Some polymers which are elastomer include polyisoprene or natural rubber, polybutadiene, polyisobutylene, and polyurethanes. These all are some elastomers. Elastomer is a big fancy word, and all it means is rubber. Some polymers which are elastomer includes polyisoprene, natural rubber, polybutadiene, polyisobutylene, and polyurethane. These all are some examples of elastomer, which is show elasticity. Elasticity means it is stretching twice or thrice its original shape. When stretching force is removed, it gets original shapes are called elastomers. It is also one of the rubber characters, but it is made by man-made vulcanized rubber. Some of the vulcanized rubbers are polyisoprenes, natural rubber, polybutadiene, polyisobutylene, and polyurethanes. These all are some elastomers prepared by man-made monomeric compounds. Why elastomer? High energy density, capable or strong storing large amount of energy with small area and volume, capable of storing large amounts of energy with small area and volume. Low strains. Stress or strain profile suitable for low power electrostatic accelerator with large displacement. These are high energy density and have low strain. Structure of elastomers, the long polymer chain. It is a long polymer chain cross-linked during the molecular structure of elastomer can be imaged as a metabole structure with the metaboles signifying cross links. It is one of the polymer chain. It have cross-linked bonds during bonding between monomer to monomer. The molecular structure of elastomer can be imaged as a metabole structure with the metaboles signifying cross links. It have cross-link structures between monomer to monomer, formation of new bond in elastomers. Some properties of elastomers. Elastomers have high amorphous material, high randomly oriented structure, large reversible extension, low intermolecular force allow for flexibility, rubberoid material, a metabole structure with the metabole signifying cross link bonded between monomer to monomer. These are characters or properties of elastomers. It have highly amorphous material. It show stretching is high stretches and after it also high tensile strength when you are applying force on elastomers. Highly randomly oriented structures. It is molded different ways. It will be stretches. Large renewable extension. Extension is very large. Low intermolecular force alone. It cannot undergoing deformation by applying more pressure on elastomers. Rubberoid material. It is has a elasticity then called rubberoid material. It have a cross-linked bond that is metal ball structures. Cross-linking structures show in elastomers. Cross-linking means that different chains of polymer molecules have all been linked. It have a cross-linking bonds. How do form cross-linking bond? Cross-linking means that different chains of polymer molecules have all been linked. How it is linking between monomer to monomer? it have a cross-linking bond. So here oxygen, hydrogen bond, oxygen, hydrogen cross-linking bond. Here also oxygen, hydrogen bond, oxygen, oxygen bond. See here hydrogen, oxygen, oxygen. These cross-linked intermolecular bonds form in elastomers. So this bond is very strong bond. This bond unbreakable by applying heat and pressure. So it is very strongest bond. So here you see one is oxygen hydrogen bond. Here also oxygen hydrogen intermolecular bonds having elastomers. So this bond is very strong bond. It is unbreakable by applying heat and pressure and also stretching. Vulcanization of elastomer. Vulcanization is a chemical process for converting rubber or related polymers into more durable material via the addition of sulfur or other equipment. Curatives. Other equipments, rubber balls obtained from a vulcanization process. What is vulcanization? Addition of sulfur. Heating of rubber with sulfur. Heating of rubber with sulfur at 110 to 140 degrees centigrade to increase the strength of the rubber is called vulcanization. In this process, vulcanization is carried out to modify some properties of natural rubber like sensitive to heat, low tensile, high absorption of water. These characters increases in vulcanized rubber. Vulcanization is a chemical process for converting rubber or related polymers into more durable materials via the addition of sulfur or other equipments. Addition of sulfur. General purpose of elastomers. General purpose of elastomers: styrene butadiene rubber, styrene butadiene rubber, polybutadiene rubber, polyisoprene rubber, natural rubber, synthetic rubber. Butadiene rubber or butyl rubber, isoprene rubber, natural rubber, synthetic rubber. Polybutadiene rubber, polybutadiene rubber, polybutadiene rubber. Butadiene is prepared by copolymerization of butadiene, copolymerization of butadiene to form butyl rubber. Butyl rubber. Butadiene CH2 double bond CH single bond CH double bond CH2 is produced by the dehydrogenation of butene or butane or by the cracking of petroleum to form butyl rubber. butyl rubber. Butyl rubber prepared from butadiene. It undergoing addition polymerization to form butadiene rubber. See here, structure of butadiene rubber. Butadiene CH2 single bond CH double bond CH single bond CH2 taken N taken N. N number of monomers interact in the polymerization to form butadiene rubber. CH2 single bond CH double bond CH single bond CH2 taken N. This butyl rubber prepared from reaction in between butadiene formula CH2 single bond CH butadiene CH2 double bond CH single bond CH double bond CH2 butadiene. N number of butadienes undergoing addition polymerization. Addition polymerization to form butadiene rubber. CH2 single bond CH double bond CH single bond CH2 taken N is called butadiene rubber. Properties of butadiene rubber: good absorption, resistance, elasticity and cold properties, low cost, all synthetic from cheap monomers, widely used in tires because of good abrasion resistance. Good abrasion resistance, elastomer, elasticity and cold properties, low cost, all synthetic from cheap monomers, widely used in tires because of good abrasion resistance. These are characters of butyl rubber. Butyl rubber. Uses of elastomers. Their common uses are as in building as sealing agent, in preparing nylon, preparing tires, in industries, in gaskets. These commonly used as in building as sealing agent. Building sealing agent compounds are made by elastomers. In preparing nylons, preparation of tires, in industrial materials are made by elastomers. Preparation of gaskets, gas supplying pipes are prepared by elastomers. Styrene block copolymers are used in shoe soles for their easy for processing and widely as adhesives. These materials find large applications in automotive sectors and in household appliances sectors. Elastomers are prepared in applications of automobile sectors, in household sectors. We prepared many items by using elastomers. Like these materials are used in automobile purpose. These are also used in household and automobile sectors. These all are made by elastomer compounds. Elastomer can be compounded or joined with other materials to strengthen. Certain characteristics can easily be next to various other materials such as metal, hard plastics, or different kinds of rubber with excellent adhesives. Elastomers being very strong when struck hard if scratched, resistant to corrosion from various chemicals and resilient in the face of humidity of or water, submarines, good electronic insulators between different branches or wires. They are dense and protectives. Elastomers can be compounded. It may be joined with other materials to strengthen. Certain characters should be increases, can easily be installed next to various other materials such as metal, hard plastics, or different kinds of rubber with excellent adherences. It is made by many compounds with addition of other materials. It shows high elasticity, easily installed next another materials such as metal, hard plastics, or different kinds of rubber. Elastomers being very strong when struck struck hard in scattered, resistant to corrosion from various chemicals and resilient in the face of humidity or water, submarines, good electronic insulators between different branches or of wires. They are dense and protective. They are easy to sculpt when they are in their softened resinous state. Yet once they are hard, they remains impervious to changes in most changes in temperature as well as stress like stretching or compression. These characters increases in vulcanized rubber or vulcanized elastomer. They are easy to scrap when they are in their softened, resinous state, yet once they are hard, there remains imperviation to changes in most change in temperature as well as stress like stretching or compressing of elastomers. Elastomers form various rubbery shape. Many industries really on parts made from elastomers, especially automobiles, sports, electronics, and assembly line factors. TPE is commonly used to make suspension bushing for automobile performance applications because of its greater resistance to deformation when compared to regular rubber bushings. This TP is commonly used to make suspension bushings for automobile performance applications because of its greater resistance to deformation when compared to regular rubber. Regular rubber. It is commonly used to make bushings for automotive performance applications because of its greater resistance to deformation. Used in adhesive paints or for example car coatings, used in cable insulations. These elastomers mainly used in adhesives, that is coatings, paints, used in cable insulators, in electronic goods, used in adhesives, paints, for example car coatings, car painting, uses in cable insulators. Elastomers are good at insulating, withstanding deformation and molding into different shapes used for wheels on sketchboards and the soles of tennis shoes to the insulation covering sparker cables and telephone lines. Elastomers are good at insulating, withstanding deformation and molding into different shapes used for wheels on skateboards and the soles of tennis shoes to the insulation covering sparker cable and telephone lines. Elastomers are good at insulating, withstanding deformation. Withstanding deformation and molding into different shapes used for wheels on skateboards and the soles of tennis shoe to the insulating covering sparker cable and telephone lines. Cable and telephone lines. Thermoplastic elastomers. TPE means thermoplastic elastomers. Classifications of elastomers. Thermoplastic elastomers. Natural rubber, thermoset by cross-linked. Synthetic rubber, thermoset by cross-linked. Polyisoprene, styrene, butadiene, rubber, chloroprene, polybutadiene, nitrile rubber, butyl rubber, silicones, ethylene, propyl, diene, monomers, etc. Thermoplastic elastomers are classified by synthetic rubber, natural rubber presence in cross-linked bond. Thermoplastic elastomers. Elastomer. An elastomer is a polymeric material that has elongation greater than 100% and a significant amount of resilience. For elastomer to experience relatively large elastic deformation, the onset of plastic deformation must be delayed. Restructuring the motions of chains part one another by cross-linking accomplishes these objectives. Cross-linking in many elastomers is carried out in a process called vulcanization. Heating with sulfur at 140 degrees centigrade. An elastomer is polymeric material that has elongation greater than 100% and a significant amount is resilience. For elastomer to experience relatively large elastic deformation, the onset of plastic deformation must be delayed. Restructuring to motion of chains fast on one another by cross-linking accomplishes this objective. Cross-linking in many elastomers is carried out in a process called vulcanization. Heating with sulfur at 110 to 140 degrees centigrade to increase strength of rubber is called vulcanization process. In this process, addition of sulfur with natural rubber or synthetic rubber to increase the strength of rubber and modify the characters between formation of new bond carbon sulfur carbon bond. It is very strong bond. It is unbreakable bond by applying heat and pressure. So this process is called vulcanization process. Thermoplastic elastomers show here. One is styrene butadiene and styrene. It is copolymer of styrene and butadiene to form Buna S rubber. Buna S rubber. Styrene CH2 double bond CH C6H5 is called styrene. Butadiene CH2 double bond CH single bond CH double bond CH2. Butadiene and styrene undergoing copolymerization to form Buna S is a elastomer. Buna S. CH2 single bond CH double bond CH single bond CH2 single bond CH C6H5 taken N is called Buna S. Buna S. These Buna S used in preparation of floor tiles, footwears, etc. It is used in automobile tires, tubes, etc. This Buna is used in cable insulator, carpet backing, etc. These are uses of Buna S. It is prepared by copolymerization of butadiene and styrene to make Buna S. It is used for floor tiles, footwears, used in automobile tires, automobile tubes. It is used in cable insulator, carpet backing. These are uses of elastomer of Buna S. Another one, neoprene rubber. Neoprene rubber. This neoprene prepared by addition polymerization of chloroprene to form neoprene rubber. Neoprene prepared by chloroprene. Chloroprene chemical name 2-chloro-1,3-butadiene. 2-chloro-1,3-butadiene formula CH2 double bond CCl single bond CH double bond CH2. Chloroprene. This chloroprene undergoing addition polymerization to form neoprene CH2 CCl double bond CH single bond CH2 taken N is called neoprene. 2-chloro-1,3-butadiene. These chloroprene undergoing addition polymerization to form polychloroprene is called neoprene. Neoprene waste burning techniques. Incinerators, some brands of do recycling process using in old neoprene to create shoe t-shirts. Neoprene rubber used for wire, cable, insulating and wiring, lining purpose are used. It is used for making shoes, gaskets and turbine for carrying corrosive gases, oil, petrol, supplying pipes. It is used for making power belts, transmission belt, conveying belts. It is also used for preparation of glosses, aprons, household articles are prepared by neoprene. Neoprene used in laptop, slaves, wet shoots, small boats, boots are prepared by neoprene rubber. It is used in wire insulating, cable wiring, cable lining, and reaction vessels are prepared by neoprene. It is used for making houses, shoes, gaskets, carrying corrosive gases, oil supplying pipes, petrol supplying pipes. It is used for making power belts, transmission belts, conveying belts. This is also making neoprene rubber. It is used for preparation of glosses, aprons, household articles. These are preparation and uses of elastomer. Disadvantages of elastomers. Disadvantages of elastomer. Elastomer has some disadvantages as much expensive elastomers, much expensive general inability to bear load, sometimes poor chemical and heat resistance, can be easily destroyed, sometimes low thermal stability. Sometimes low thermal stability. Some of the disadvantages there. Elastomer, high expensive material. Generally, inability to bear load. Inability to bear load. Sometimes poor chemicals and heat resistance. Sometimes poor chemicals and heat resistance can be easily destroyed. Sometimes low thermal stability are in elastomers. Preventing from being used in high-speed automobile tires, relatively high cost of raw material, poor chemical and heat resistance, high compression set and low thermal stability. These are disadvantages of elastomers. Preventing from being used in high-speed automobile tires, relatively high cost of raw material, poor chemical and heat resistance, high compression set and low thermal stability. This is about elastomers. What is elastomers? How to make elastomers? Preparation, uses of elastomers, disadvantages of elastomers. Elastomer is a man-made vulcanized rubber like polymer which can be stretching at least twice or thrice its length. But when the stretching force is removed, it gets original shape is called elastomer. Some of the elastomers: butyl rubber, vinyls, neoprene rubbers. These are uses are discussed in this hour and also disadvantages of elastomers. Thank you once again.